The question pertains to the application of National Electrical Code, or NEC, Section 110.26 concerning working space about electrical equipment. Specifically, it addresses a scenario where an air handling unit, or AHU, located on a roof has heat pipes positioned approximately 1 to 2 feet in front of the disconnect switch and service panel. The primary concern revolves around whether performing service or maintenance on these heat pipes after de-energizing the unit from its power source in the basement constitutes a violation of the NEC. NEC 110.26 mandates specific dimensions for working space around electrical equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. These dimensions are detailed in Table 110.26 of the NEC, which specifies the required depth of the working space based on the nominal voltage to ground and the condition of the installation. Condition 1, as defined in the NEC, applies where there are exposed energized parts on one side and no live or grounded parts on the other side of the working space, or where exposed energized parts are on one side and grounded parts are on the other side, but are protected by insulation or other suitable means. Condition 2 applies where there are exposed energized parts on one side and grounded parts on the other side. Condition 3 applies where there are exposed energized parts on both sides of the working space. The depth of the working space, as specified in Table 110.26a, varies depending on the voltage to ground and the condition. For example, for equipment operating at 151 volts to 600 volts, Condition 1 requires a minimum depth of 3 feet, Condition 2 requires 3.5 feet, and Condition 3 requires 4 feet. These clearances are crucial for ensuring the safety of qualified electrical workers who may need to perform tasks such as troubleshooting, repairing, or inspecting the electrical equipment while it is energized. The height of the working space is also addressed in NEC 110.26c, which requires that the working space be clear and extend from the grade, floor, or platform to a height of 6.5 feet or the height of the equipment, whichever is greater. This ensures that workers have adequate headroom to perform their tasks safely. Furthermore, the width of the working space is addressed in NEC 110.26 AHU, which requires the working space to be at least 30 inches wide or the width of the equipment, whichever is greater. This ensures that workers have sufficient lateral space to maneuver around the equipment. Now, to address the specific scenario presented regarding the AHU and its heat pipes, it is essential to understand the intent and application of these clearance requirements. The clearance requirements in NEC 110.26 are specifically intended to provide a safe working environment when the electrical equipment is energized. The NEC states that these clearances are required for equipment that is likely to need examination, adjustment, servicing, or maintenance while energized. This implies that if the equipment is not energized, the clearance requirements do not apply. In the given situation, the plan is to de-energize the AHU from its source in the basement before performing any work on the heat pipes located in front of the disconnect switch and service panel. By de-energizing the unit, the electrical hazards associated with working on or near energized equipment are eliminated. This fundamentally changes the nature of the task and its associated risks. When the AHU is de-energized, there are no exposed energized parts in the vicinity of the heat pipes. Therefore, the risk of electric shock or arc flash is essentially removed. In this state, the clearance requirements of NEC 110.26 no longer apply because the primary purpose of these clearances is to protect workers from electrical hazards that are present only when the equipment is energized. To further clarify this point, it is helpful to consider the definition of energized as it is used in the NEC. The NEC defines energized as electrically connected to a source of voltage. Conversely, de-energize means that the equipment is not electrically connected to a source of voltage. When the AHU is de-energized at its source in the basement, it is no longer electrically connected to a source of voltage, and therefore, it is considered de-energized. Consequently, the clearance requirements of NEC 110.26 do not apply. It is important to emphasize that while the NEC clearance requirements do not apply when the equipment is de-energized, other safety precautions should still be taken to ensure a safe working environment. Firstly, before commencing any work on the heat pipes, it is crucial to verify that the AHU is indeed de-energized. This can be accomplished using a reliable voltage testing device to confirm that there is no voltage present at the disconnect switch and service panel. Secondly, a lockout/tagout procedure should be implemented to prevent the AHU from being inadvertently re-energized while work is in progress. This involves placing a lock and tag on the disconnect switch in the basement to indicate that the equipment is being worked on and should not be energized. Thirdly, appropriate personal protective equipment, or PPE, should be worn, even though the electrical hazard has been eliminated. This may include safety glasses, gloves, and other protective gear, depending on the nature of the work being performed on the heat pipes. Fourthly, it is essential to follow all applicable safety procedures and guidelines established by the employer or facility owner. This may include specific procedures for working on HVAC equipment, as well as general safety rules and regulations. By taking these additional safety precautions, it is possible to ensure a safe working environment even when the NEC clearance requirements do not apply. In summary, de-energizing the AHU from its source in the basement before performing work on the heat pipes does not violate any requirements of NEC 110.26a. The clearance requirements in this section are specifically intended to provide a safe working environment when the electrical equipment is energized, and they do not apply when the equipment is de-energized. However, it is essential to take other safety precautions, such as verifying that the equipment is de-energized, implementing a lockout/tagout procedure, and wearing appropriate PPE to ensure a safe working environment. Furthermore, it is always advisable to consult with a qualified electrical professional or local electrical inspector to ensure compliance with all applicable codes and regulations. This can help to avoid any misunderstandings or potential violations and ensure that the work is performed safely and correctly. It is also important to keep in mind that the NEC is a minimum standard, and in some cases, it may be necessary to exceed the requirements of the code to ensure a safe working environment. For example, even though the NEC may not require specific clearances when the equipment is de-energized, it may still be prudent to maintain a reasonable amount of clear space around the equipment to facilitate access and maneuverability. This can help to prevent accidents and injuries and make the work easier to perform. In addition to the NEC, other codes and standards may also apply to the installation and maintenance of electrical equipment. For example, the National Fire Protection Association, or NFPA, publishes a number of standards that address electrical safety, including NFPA 70 Standard for Electrical Safety in the Workplace. This standard provides guidance on how to protect workers from electrical hazards, including arc flash and electric shock. It is important to be familiar with all applicable codes and standards and to follow them carefully when working on or near electrical equipment. Another important consideration is the training and qualifications of the workers who are performing the work. Only qualified electrical workers who have received adequate training and instruction should be allowed to work on or near electrical equipment. These workers should be knowledgeable about the hazards associated with electrical work and should be proficient in the use of appropriate safety procedures and equipment. In addition to formal training, it is also important for workers to receive ongoing on-the-job training and mentoring. This can help them to stay up to date on the latest safety practices and to develop the skills and knowledge necessary to perform their job safely and effectively. Ultimately, the goal of all electrical safety efforts should be to create a safe working environment for all workers. This requires a commitment to safety from everyone involved, including employers, employees, and regulatory agencies. By working together, it is possible to reduce the risk of electrical accidents and injuries and to ensure that electrical work is performed safely and efficiently. It is also worth noting that the interpretation and application of the NEC can sometimes be complex and subject to different interpretations. Therefore, it is always a good idea to consult with a qualified electrical professional or local electrical inspector if there is any doubt about the meaning or application of a particular code requirement. These professionals can provide valuable guidance and assistance and can help to ensure that the work is performed in compliance with all applicable codes and regulations. In the specific case of the AHU and its heat pipes, it may be helpful to consult with a mechanical engineer or HVAC technician to determine the best way to perform the maintenance work safely and efficiently. These professionals can provide insights into the design and operation of the equipment and can help to identify any potential hazards or challenges that may need to be addressed. They can also provide guidance on the selection and use of appropriate tools and equipment and can help to ensure that the work is performed in accordance with industry best practices. In addition to the technical aspects of the work, it is also important to consider the human factors that can contribute to accidents and injuries. These factors may include fatigue, stress, distractions, and poor communication. To mitigate these risks, it is important to ensure that workers are well rested, alert, and focused on their tasks. It is also important to provide them with clear and concise instructions and to encourage them to ask questions if they are unsure about anything. Furthermore, it is important to foster a culture of safety in which workers feel comfortable speaking up if they see something that is unsafe or if they have any concerns about the work being performed. In conclusion, the question of whether de-energizing an AHU from its source in the basement before performing work on the heat pipes violates NEC 110.26 can be answered definitively in the negative. The clearance requirements of NEC 110.26 apply only when the electrical equipment is energized. When the equipment is de-energized, these requirements do not apply. However, it is essential to take other safety precautions to ensure a safe working environment. These precautions may include verifying that the equipment is de-energized, implementing a lockout/tagout procedure, wearing appropriate PPE, and consulting with qualified professionals. By following these guidelines, it is possible to perform the work safely and efficiently and to avoid any potential violations of the NEC or other applicable codes and standards. Remember, safety should always be the top priority when working on or near electrical equipment.